All right, today we're going to dive into a mathematical puzzle that seems, well, completely impossible at first glance.
You probably remember factorials from school, right? 4 factorial is just 4 times 3 times 2 times 1, which gets you 24. Pretty simple. But have you ever stopped to think, what is 1/2 factorial? I mean, how do you even do that? How can you multiply a descending list of numbers when you start with a fraction? The question itself just feels wrong.
Well, here's the thing. The question isn't broken at all. We just need a better tool to crack it open. The answer requires a much more powerful and, honestly, a much more elegant idea.
And that idea, that's the hero of our story today. So let's meet the gamma function. So what exactly is this thing? The gamma function, which we write with the Greek letter gamma, is this incredible function that basically takes the whole idea of the factorial and blows it wide open. It lets us move beyond just whole numbers and find answers for almost everything else: fractions, decimals, even complex numbers.
Here's the best way to think about it. Imagine the regular factorial is like a staircase. You can only stand on the solid steps: 1 factorial, 2 factorial, 3 factorial, and so on. There's just empty space in between. What the gamma function does is it paves over that staircase and turns it into a perfectly smooth, continuous ramp. Now you can find a value for any point along the way.
And here's how it connects directly. For any positive whole number you can think of, let's call it n, the gamma of n is exactly the same as n minus 1 factorial. So the gamma of 5 is just 4 factorial, which is 24. It lines up perfectly on all the old steps, but now it fills in all the infinite gaps in between.
But how does it do that? I mean, how does it know what value to take between the steps? Let's take a look at the function's master key. This right here, this is the secret sauce. It's called the recurrence relation. Gamma of z plus 1 equals z times gamma of z. This one simple, beautiful rule is basically the function's DNA. It defines how it behaves absolutely everywhere, and it lets us figure out any value as long as we know another one nearby.
So we've got this incredible, smooth ramp that connects all the numbers. But are there any spots where it's broken? Any points where the function just completely falls apart? Turns out, yes, there are. And it's actually pretty easy to see why if we just flip that master key formula around a bit. If we solve it for gamma of z, we get gamma of z plus 1 divided by z. So what happens if we try to find the gamma of 0? Well, that z on the bottom becomes 0, and we all know the number 1 rule in math: you can't divide by 0. The whole thing just breaks. It's undefined.
And this isn't just a problem at 0. The same issue pops up again and again at all the negative whole numbers: -1, -2, -3, and on and on. We call these points the poles of the function. They're the only spots where our otherwise perfectly smooth ramp has these giant infinite breaks. Okay, so we've explored the function's power and its limits, but now we get to the really mind-blowing part, the big payoff: a truly shocking connection to one of the most famous numbers in the entire world, pi. So let's circle all the way back to the question that started us on this journey. What in the world is 1/2 factorial? Well, using our new gamma function, we know that's the same as asking for the value of gamma of 3/2. And to get that, we first need to figure out the value of gamma of 1/2. And the answer is the square root of pi. I mean, just let that sink in for a second. A function that we created to generalize multiplication turns out to be fundamentally connected to the ratio of a circle's circumference to its diameter. It's one of those moments in math that is just unbelievably cool. And once we know that one amazing fact, that gamma of 1/2 is the square root of pi, we can use our master key, that recurrence relation, to unlock a whole universe of other values. So to find gamma of 3/2, which is the answer to our original 1/2 factorial question, we just follow the rule. It's 1/2 times gamma of 1/2, which gives us the square root of pi divided by 2. Simple as that. Now, this is all fascinating stuff, but you might be asking yourself, so what? Why does any of this abstract math actually matter in the real world? Well, it matters a lot. The gamma function isn't some dusty old idea. It's a foundational tool, a real workhorse in tons of fields. In statistics and probability, it's the absolute backbone of really important probability distributions that we use to model the world.
And in higher-level math like complex analysis and calculus, it just pops up everywhere, helping us solve ridiculously complex problems. You could really boil it down to this. The gamma function is an indispensable tool across many fields of mathematics and science. It's a non-negotiable part of the toolkit for scientists, engineers, and statisticians all over the world. So think about it. We started with a simple question about factorials that seemed impossible, that seemed to break the rules, and the journey to find the answer led us to this beautiful, powerful new idea that somehow connects multiplication, calculus, and even the geometry of a circle. It really makes you wonder, what other mathematical rules are just out there, waiting to be beautifully broken?